Hi guys, I'm going to show you two examples today that are both going to be about hypothesis testing, but both of these are going to be to do with a two-tailed test. One of the key differences with a two-tailed test is shown in our alternate hypothesis. Whereas with a one-tailed test, we're usually looking in one direction. So the alternate hypothesis would be looking for either an increase or a decrease in the probability. For a two-tailed test, we could be looking for any kind of change. So this could be an increase or a decrease. One of the key things that also does is because of that means that we will need to halve the significance level, because that significance level is spread over the two tails. And in the examples we're going to look at, that will be shown, and I'll emphasize that when we get there. So in this first example, we've got two different parts of this question that we're going to look at. We're told that this example can be used with a binomial distribution. We've got a value of n as 40. Null hypothesis is that the probability is equal to 0.25, and our alternate hypothesis is that the probability is not equal to 0.25. So that's already one of the differences we can see between a one-tailed test and a two-tailed test. At the moment, we're just trying to prove that the probability is not equal to 0.25. What we're not interested in is whether that is greater than or less than 0.25. Now, the question then says for each of the following values, and we'll get to those values in a second, we're going to firstly state the p-value to 4 decimal places, and also we're going to want to then state with a clear reason our conclusion for the hypothesis test at a 10% significance level. Before we even start this and before we consider these values here, we're going to think about our expected value for this. So in the question we can see that we've got a value of n as 40 and a probability of 0.25. So if we were going to do our value of n times by our probability of p, that will give us an expected value. So if we do 40 times by 0.25, that will give us a value of 10. And that's going to be our expected value. Now in this question, we aren't given any context. So we don't know what it is in relation to, but we know the expected number would be 10. Now what we need to do for the first part of this question, for part A, we are given a test statistic, x is equal to 7. Now, usually, we can look at our alternate hypothesis to decide on whether we are going to be looking at less than or greater than the test statistic for our p-value. We're not given that for this. So with a two-tailed test, we need to consider the test statistic and we need to consider our expected value. The expected value here is 10. That tells us that that is the most likely outcome. Now, 7 is the value that we want to test. That is less than 10. So when finding our p-value, we're going to be looking at the probability that x is 7 and more extreme, which would be less than or equal to 7. So here we're going to be finding out the probability that x is less than or equal to 7. And we can do that on our calculator. So if we use our binomial distribution, so we're going to distribution, we're going to go to binomial CD, we're going to use a variable. Our value of x here is 7. We've got n is 40, and we've got a probability of 0.25. And if we do that to 4 decimal places, that will give us a value of 0.1820, like we've got there. So that's our value of the p-value. Now, don't forget in the question here, for the part 2, we also want to then think about a conclusion for our test based on the hypotheses. So for the next part of this, we need to then obviously go on to compare this with the significance level, like we've looked at in previous examples. What we need to remember is that because this is a two-tailed test, our significance level is split over both the lower and the higher tail, even though we're only looking at one of those tails. So this value, our p-value here, is actually going to be compared to half of 10%, which is 5%. And in this case here, we can see our value of 0.1820 is greater than 0.05, where that's our p-value. And that is our significance level split over the two tails. Now, in this circumstance here, because we can see the p-value is greater than the significance level, we would then choose to accept our null hypothesis. Now, we aren't given any more context within this question, so we can't give a conclusion, we can't say anything else other than the fact that we would accept the null hypothesis in this circumstance. So let's do a very similar thing, and we're going to do this for the other one now. We're going to do this for x is equal to 16. So here we've got a test statistic of 16. This is going to be slightly different because our test statistic here is above our expected value. So when we're finding our p-value, we're finding the probability that it's going to be either 16 or more extreme, we're going to be looking at greater than or equal to 16. So the probability that x is greater than or equal to 16. Obviously on our calculator we can't work that out. We can only work out probabilities that are less than or equal to. To be able to do that, we would need to take away the probability that x is less than or equal to 15 from 1. So on our calculator now, we're going to change it so we're looking at less than or equal to 15, n is going to be 40, p is 0.25, and that gives me that value there. If I subtract that value from 1, then to 4 decimal places, we get 0.0262. So our p-value will then be compared with our significance level. Our significance level is exactly the same for this one, and split across the two is going to be 0.05. Now our p-value here, 0.0262, is now less than our significance level. And because that's less than the significance level, we would then choose to reject our null hypothesis and accept our alternate hypothesis, whatever context this question was going to be about. Okay, so we've looked there at using a two-tailed test, an example where we would accept, an example where we would reject our null hypothesis, and we've looked at the two different test statistics that we could be given. I'm going to look at another example with you now, and this question is going to bring in more context. And whereas here, where we were given the hypotheses in the question, in the next one we will need to write those ourselves and think about stating that and showing that this is actually can be used using a binomial distribution. So the next question here that I've got, I'm going to read out, and as I said, this has got more context to it. So it says, an anti-smoking campaign is held in a city. Before the campaign, health workers estimated that 30% of adults smoke cigarettes. Sometime after the end of the campaign, a survey is conducted to find out if it has had any impact on the number of smokers, positive or negative. So already we can see a bit of a clue here that this is going to be a two-tailed test, because they're not looking at either an increase or a decrease in the number of smokers. They're interested in any kind of change, whether that's positive or negative. For the next part of this, it says a random sample of 15 adults are selected. When the data is analysed, it is found that the sample contains exactly 2 smokers. So 2 smokers is going to be our test statistic. And we want to test this at the 5% significance level. And at that 5% significance level, we want to know if there's sufficient evidence to suggest that there has been some kind of change in the number of smokers. Another clue that this is a two-tailed test is that we're being asked to investigate whether there is any change in the number of smokers, not that they've either increased or decreased. So we're going to start here by showing that we can represent this using a binomial distribution. I'm going to introduce x as the random variable that is going to represent our number of smokers, and this can be distributed binomially using a value of n is 15, because 15 is the total number of pieces of data that were collected. Our probability here was 30%, so I'm going to write that down as 0.3, and we're going to say this is where x represents the number of smokers. Okay, now we're going to write our 2 hypotheses for this test. So our first hypothesis is going to be an equality, and our first hypothesis will be that the probability is equal to 0.3, what we're given in the question. Our alternate hypothesis will be that the probability is not equal to 0.3, because remember, we're not interested whether it's increasing or decreasing, just that there is going to be some kind of change within that probability. And the other thing that I'm going to write down as well is our test statistic. We were given this in the question. So our test statistic is x is equal to 2. Now, before we can think about our p-value, the next thing that I would advise working out is going to be our expected value, our expected number of smokers in this case. And we'll do so by working out n times by the probability. So n is going to be 15. Our probability is 0.3. And if we times those two together, that's going to give us a value of 4.5. So 4.5 is the number of smokers we would expect if 30% of our sample were smokers. Now, if we compare that with our test statistic, we can see that our test statistic is lower than our expected number. So when we're finding our p-value is the probability of being equal to our test statistic or more extreme. We are going to be looking at less than this value. So the p-value is going to be the probability that x is less than or equal to 2. And again, this is a value we can work out on our calculator. So if we go into our binomial distribution, cumulative distribution, if we put in a value of x of 2, because we're looking at less than or equal to 2, our value of n is going to be 15, and our value of p is going to be 0.3. And that is going to give us to 3 significant figures 0.127. So that's our p-value. And the next step is obviously to compare our p-value with our significance level. So we've got a p-value of 0.127. Our significance level was given in the question as 5%. But remember that this is a two-tailed test. We need to split and separate that over the two tails. Now we're only looking at the lower tail because we're looking at whether it's less than or equal to 2. But we still need to separate it over those two. So the p-value, the significance level we're going to compare this with is going to be 2.5%, which is 0.025 as a decimal. Now actually, it doesn't matter. No matter which of those values it was, the p-value is still going to be greater than it anyway. And obviously, because our p-value is greater than our significance level there, so our p-value and our significance level, because there it is greater than it, then we would choose to accept our null hypothesis, like we've looked at in other examples. So we choose to accept our null hypothesis. Now, the only thing that we can do just to finish this off that we couldn't do in the examples before is we can give a conclusion because we've got context to this. If we've chosen to accept our null hypothesis, we've not managed to prove our alternate hypothesis, which we're proving. So it's worth then taking a look back at the question and thinking about what conclusion we can draw from this. So because we haven't proven that, we would then say that there is insufficient evidence to suggest that there has been any change in the number of smokers. Because this is what we were looking at testing. We were looking at seeing whether there was any change in the number of smokers. We weren't interested as to whether this was going to be either increasing or decreasing. And because we chose to accept a null hypothesis, there is insufficient evidence to show that this has changed. So clearly, if we were going to use another test statistic, our value of 2 would have had to have been further away from our expected number to be able to prove this. So would have needed either significantly less smokers than 4.5, even more so than 2, or significantly more smokers to have proven that the probability or the probability of the number of smokers would have changed in some way. Okay, so we looked at two examples there, one without context and then one with context, and we've taken a very similar approach here. There's just a few slight changes with it now being a two-tailed test. Thank you.